All right, hello, happy Monday night. Thanks for joining me. First off, I want to say good luck to all the volleyball girls if you haven't played yet, or if you've already played. I hope that you did your best, and I can't wait to hear about it tomorrow in class. But let's go ahead and get right down to some pre-algebra. So in our second unit, we're starting it today, and our unit 2 is all about equations and solving those equations. And I know there's some of you that are thinking, why are there letters in algebra? Why are there letters in math? Math is just numbers. Well, you're sort of right, but sometimes we don't know what we need in a problem to make it true, so we represent that missing part with a letter, and that letter is called the variable. It's called the variable. So if you hear me throw around some of that language like, where's the variable, isolate the variable, that's what I'm talking about, the letter in the math problem. And you might see it written in many ways. Most commonly it's an X, it could be a Y, an M, an N, a Z, or any other letter. They're all variables, okay? So before we get started, we need to write down some notes, okay? So write these notes down for me. The goal to solving an equation is to find the value of the variable. There you go. There's that word again. So we can do that by isolating, there's another word that I already used, isolating the variable, which is just a fancy way for saying getting the X alone and positive, can't be negative. That's just a fancy word for saying isolating the variable really means getting the X alone and positive, or whatever letter you're using there, okay? And let me just make a note here that an equation is anything with an equal sign. It has an equal sign. You'll see with the next thing that we're doing, when we use greater than, less than, or equal to, those are called inequalities. So I just want to point that out now, and you'll see why later. Okay, so when solving equations, so now we know the goal, okay? So the next thing we need to know is when solving equations, we use opposite operations I'll tell you more about that later, period. So what that means is whatever was done to the variable we must, it's not just a suggestion, we must do to the opposite side. Okay, so if you need to pause and get all those notes in, you can do that now, and then just come back when you're ready. So here we're going to start some examples. These are just one-step equations, and hopefully this will be a review from 6th grade. You did one-step equations in 6th grade. So here's an example. X plus 7 equals a negative 23. So go ahead and write that down. All right, so let's look back up here to our rules. Our goal is to find the value of the variable. We have to do that by getting this x by itself. Right now it's attached to the 7 through addition. So we need to get that, get this part, the plus 7, we need to get that off of this x because we need to get this x by itself. I guess you can think of it as the x does not play well with others. We have to get the x by itself. Okay. So to do that, we use the opposite operation. So here we have addition. We need to use subtraction. This is addition. So we're going to use subtraction to get this 7 away from the x. All right? So what we have to do, what we do to one side, we have to do to the other side. So to get that off, we have to say, well, there's adding here, we're going to have to subtract. So from both sides of the equal sign, we're going to subtract. We're doing the opposite. It's adding 7, we're going to have to subtract 7 from both sides. That's an important thing. Well, when you have a positive 7 and you subtract 7, you end up with 0, which is what we want because now the x is by itself. Plus 0 means nothing, okay? And then we still have the equal sign. And now we have negative 23 minus 7. We know from our rules that same signs, okay, so when subtraction, change the signs. So plus and negative. Same signs, add and keep, okay? So we're going to add those together. We're going to keep the negative because both were negative. And now we have a negative 30. X equals negative 30. That's your answer. So now you can go back in here. The cool thing about equations is you can go back in here and you can substitute your answer for the x and show that it's correct. So let's do that. So our x value that we got was negative 30, so we're just going to rewrite the equation and plug in negative 30 to where the x is, so right there, plus 7 equals negative 23. Is this a true statement? Well, negative 30 plus 7 is negative 23. Does negative 23 equal negative 23? Yes, this is true. Okay, so let's do the next problem. Let's do one more practice. Checking my time here. Okay, we're good. All right, another practice problem. Negative 6x equals 48. Okay, so then we have to say we got to get this x by itself. Well, we have to see what is attached to the x and get that off. What's a negative 6? And it's how is it attached? There's no plus sign. There's no subtraction sign. There's no division sign. Is there a multiplying sign? No. But is there multiplication going on? Yes. because when we know our multiplication rules, we know that sometimes if there's not a sign there, it's understood that multiplication is happening. 6 times x is what this is. Negative 6 times x is a negative 6x. So if there's multiplication, we are going to need to do the opposite. And the opposite of multiplication is divide. We have to divide. So we're going to divide just like by that number, by negative 6 on both sides. Okay, so you have a negative 6 divided by a negative 6. That cancels out. All you have left is your x. 48 divided by a negative 6. Well, that leaves you with a negative 8. So this is your answer, negative 8. So let's plug that in. Negative 6 times a negative 8, which is what we found out would be our x. Oops. There you go. This is where the x is. Equals 48. Is this a true statement? Negative 6 times negative 8. A negative times a negative equals a positive. 48 is 48. Yes, it checks out. Okay. We are going to do one more. I know I said one more a while ago, but we're going to do one more because I want you to see a one-step problem with division, holding it to the problem. So x over 9 equals 27. So what we have here, holding the number to the x, this is division. So we gotta multiply. Okay? So we're gonna multiply both sides by 9. So both sides by 9. Sorry about that. So when you multiply this by 9, it's like you're saying 9 over 1. You get a 9x over 9, which just cancels out the 9s, and you're left with an x. And then 27 times 9. You do 27 times 9. 9 times 7 is 63. 2 times 9 is 18. Plus 6 is 20. I got sidetracked. 243. And it's positive because there was nothing negative here. Okay? 243. And that's your answer. If you want to check it, you can plug this in to where the x is, divide by 9, and you would get 27. Check. Alright? So just remember, to get x by itself, you have to see what is going on to get what is happening to attach the number to the x, and you have to do the opposite on both sides. Alright? Bring these notes tomorrow to class. We're going to do a fun activity in class with this, where it involves some art and coloring with a little math, right? Okay, see you tomorrow. Bye.